Control and instrumentation cables are multiple conductor cables, or you can say multi-core cables, that convey low energy electrical signals used for monitoring or controlling electric power system and their associated process. These cables carry signals from one point to another but without any distortion. They can be categorized in instrumentation cables, control cables, and data cables. Ideally, the signal at the receiving end should be identical as sending end, but in practice it can be either smaller, delayed, distorted, mixed with other signal, and mixed with noise. The degree of impairment depends upon how precisely the cable is manufactured, selection of raw material, electrical environment, and design of cable. Now let us discuss what is that causes distortion of signals. Or primary parameters which affect the transmission. These are resistance, mutual capacitance, inductance, and conductance. Based on primary parameters, performance of cable can be described in form of impedance, attenuation, and crosstalk. Now let me briefly tell you. Impedance is the opposition offered to the flow of current in an AC circuit because of resistance, capacitance, and inductance is known as impedance, or it is contribution of both resistance and reactance. Attenuation is the loss of signal strength in networking cable or connections. This typically is measured in decibels or voltage and can occur due to the variety of factors. It may cause signals to become distorted or indiscernible. Crosstalk is type of noise or interference that occurs when signal transmission of one pair interferes with the other. Crosstalk usually occurs as a result of some undesired coupling between the pairs. Crosstalk occurred at transmission end is called near end crosstalk, and at the receiving end is called far end crosstalk. The figure given on this slide is showing near and far end crosstalk in simplified way. Now, how to control these parameters in practice and what is needed for distortion free transmission? It is control on resistance and resistance unbalance, control on capacitance and capacitance unbalance, selection of insulating material, thickness of insulation to meet mutual capacitance requirement, concentricity of insulation, selection of individual pair lay and pair techniques, assembly of pairs, and screening.